Okay. Um, first things first. So I'm going to get to the end of the material. I'm going to draw a line today for test two. There isn't a big stack of homeworks for good or for bad. Prep you for test two. There's kind of what's in there. We'll still take a day to talk over whatever questions you might have. Let me direct my attention to certain, topics I want to make sure you're thinking about. But pretty much any day next week would do for that prep day, and any day would do for the test. You do it on Friday again if you want to go to the end of the week. I'm going to give you another lab this week, Friday. So, yeah.
I saw a decent number of handouts when you said Friday. So
Yeah.
I think that's agreeable around the room. Yep. If that is, and then
Okay.
and this is now, that first part was maybe speaking to the class, second part just speaking to me.
Hmm.
The first test we went into it, not that it was trivial stuff, but I felt like I knew, hey, if I can exhibit skills A, B, and C,
Yeah.
I will probably be successful in this test.
Yeah.
And if I cannot, I'll do that.
Yeah. Yeah.
I feel less comfortable that I know where the bar is on this one.
You should. Yeah, it's just this stuff's more squishy. And I just have not found a way to reduce it to skills, except with some particular cases. Like the stuff we're doing right at the moment with tabular kicking. Right? That's a kind of a skill.
I found the previous exams to prep for the last one helpful. Is that something we'll be able to do on this one?
No, I only have one exam for this. This material is all much newer.
You know, I had to shoot my shot.
Yeah. No, it's fine. And well, I mean, that should motivate you the more to ask pointed questions when we do review. And yeah, I think that's all I can say about that. And then we'll make plans going forward. So there was a whole quite substantial logic unit to this class, which is more like that first unit. So it's better classroom material. It's not easy by any means, but it's more kind of cut and dry. What you need to know. The thing is, logic just has not. I just don't see it. It's not easy. And what are we going to get out of it? I might take like a day just to kind of talk through what kind of logic-based systems are out there. But with the exception of radiant mercury, I don't know if any of you even know what that is. Radiant mercury is the thing you'll probably touch. Those of you who go to training billets in the future. You use it when you've got multiple simulations and they're not all at the same level of classification.
Radiant mercury has been in my life for a while.
Okay.
Because they actually don't know how much they're talking about here, but yes, if you get, as soon as you're trying to be able to have one guy who's training at a certain level interact in some meaningful way past the effects of what he's doing at one classification with different
radiant mercury is supposed to help you with.
It's not always easy.
Okay, yeah, I wouldn't say it is, but that's a logic-based system. But did our students get involved with building it? No. Are they involved with extending it? No. Are there other systems on the horizon? No, as far as I know. I've been here 25 years, and I think maybe 2 or 3 students that I've had have done something logic-based, at least partially, in their thesis, and that was over a decade ago. So, I mean, with that context, I'm not sure what we'd be doing, spending time on logic when we could be doing admittedly sloppier kind of coverage of much more complicated systems, but like actual systems that may impact you. So I think that's the way we're going to continue to steer, though there is some pain associated with that. Let's see. All right, I think that's all I needed to cover on the administrative side. If we're going to do the test Friday, we can do the prep day, probably Wednesday or Thursday would probably make the most sense for that.
either or?
You think that the prep day will give us things to leave with and go study, in which case maybe.
Possibly.
Would be good?
Yeah, I mean, I don't know. It shouldn't, because it's just, I'm just going to point your attention to stuff that was in the slides that went by. You know, it's nothing. It's not going to be anything that was hidden from view. But maybe. Yeah. So I don't know. Well, we can think about that. Figure that out. But it'll be one of those days. Okay, then test. It is a pencil and paper test, no electronic, same conditions as the other test. All right. All right. So let's back up now. So this is what we spent time on yesterday. How did this settle for you? So this is the kind of thing that you should understand quite well. Itai?
Like for the first one, you will add examples. Test examples.
What's that?
You will add test examples. Like
I will not. Yeah, the ones that are there are already in the lecture slides. Yeah. There is a second example of this that we'll take a look at today. Yeah, and in both of those cases, you should know these very well, right? It should not be a mystery when the thing steps, what numbers are going to change at the bottom, or exactly how they're going to change, even to that level. I would know that, and additional things about what's the point of this whole exercise. That's what I'm trying to suss out, how well you understand that.
Hey, sorry for the million questions, Dave, but when I was running through this last night, I ran into some points where I did not successfully predict. You know what? It's easy when you're like, hey, getting to C, what will it be? But there were some points where I did not think there would yet be a value on a trail to C. Does that make sense? You know, that as the value sort of promulgates or percolates out, could you just do a quick review of the point that if it went up from a couple squares away, when that extra value comes in? Does that make sense? So initially, when I find C in this case, B or F, depending on where I came from,
Right.
will also receive a value.
Right, wherever you came from, right?
Yep. And then, but I, A, or excuse A, E, or I would not have it.
No, you'd have to move from A to somewhere that had the value for
Okay.
those to get updated.
So then the second time I come by, if I go to the other one, so if I went through B last time,
Yep.
this time I come to F, it is a completely novel situation that will also create no value out to A, E, or I.
Correct.
Whereas if I went to the first one again, if I go on B the first time, now I come back to B,
Mhm.
now that trail is one further out.
Yep.
Okay.
Yep. I mean, that's the big pattern, right? Which is a good starting point, and you're at a good place for right now, but you want to be able to not only say that, but also say specifically how that number is going to change.
Yeah,
Right.
And the way that number changes is going to be 10% of whatever it got to, whatever it came to. Well,
Yeah.
and
10%, there's your 10% there of, immediate reward plus blah, blah, blah. And this is what's telling you you're going to pull numbers. You're going to pull numbers that have to do with the best number from the state you went to, right? That's what this is saying here. The best action. This is the value that's associated with that best action. Okay. So that's what makes what you said true. So, all right.
Thank you.
We're going to do another example today, and hopefully that will clarify things, maybe. And if not, that's the kind of thing we can do if come next Wednesday, Thursday, whenever we do review, if you want to do more with these, because there isn't a lot, after I talk for 10 minutes, I probably have pointed out most of the things I want to direct your attention to. We can certainly do more of that. Okay, now this is another example here, which is, I think, feels a lot different to me, yet it's reinforcement learning and uses the exact same update equation as the last one. It's tabular Q learning. Okay, so let me read this to you and to me here. It's past a little weird. Let me see. Diagram, but maybe it doesn't kick off till we take a step. I'm going to take a step first and then talk about it. Okay. All right. So this is a string copying. Again, easy peasy stuff because these are just elementary examples to illustrate the algorithm. So here we have a string. It happens to be all A's. It doesn't have to be all A's. That could be better if it's almost anything other than all A. There we go. We got a B. Okay, so that's a string. We want it copied down here. This is the cursor. Okay. Now, where is it? I think cursor at second letter, but it's kind of odd. Make this refresh again. Let's see if that's maybe I fat fingered something. Oh, because I'm taking one step to get it to register. Okay. The cursor starts all the way to the left. Okay. And then it generally moves right. And you can take some actions, which I will describe, and get some rewards, which I'll describe. But the point is, you want to copy this string down here. So our actions are, you can move left or right along the string. That means move the cursor left or right. You can insert a character at the current location of the cursor into the string down below. A reward is provided when and only when the agent moves off the right end of the string. It has to go all the way, it'll be pointing at this, and then if it moves right again, that's the point at which a reward is provided. It's the only point. Okay, and what is that reward? It's 100 per correct character in the new string. So it would be 0. If I just move right, and move off the end, I'll get a reward of 0. Okay? All right. And at which point a new string would pop up, the cursor would reset, I believe, and it would just keep going on again. Okay. The state provided to the agent is a string composed of the characters in the original string and the copy at the current sensor location. Okay, so that's what I'm showing right here. This weird thing is just saying that, okay, this is what's in the current string where we are. This is what's in the current location of the copy where we are. So A understring, A blank. Okay. The last state we were in, well, when we were over here, that was also A blank. Okay, our last action was to move right, and we were in exploit mode. Okay. Now, this down below is almost, oh, it is the entire Q table. Right. And here you go. Okay, so these are A's. Structure really needs refreshing. These are A's. Okay, so state AA. So there's an A in the original, and there's also an A in the copy there. There's an A in the original, but there is incorrectly a B in the copy, and on and on. Yes, good. Okay, actions we could take: write A or B into the copy at that location, or move the cursor left or right. So, good. Great. All right. All right. So let's take a look. So right now, what's going to happen? We're in exploit mode on the next step, which is 90%. 90% of the time we'll be in exploit mode. What are we going to do? This is our state. We'll take the maximum, take the best, random. It's going to be random. Yeah, it's going to be just the same as if we were doing an exploit. Okay. And with this problem, it's going to maybe stay like that for a little bit. So let's see if we can actually. Okay, it decided to move right. It's in exploit mode again. Oops, that finger. Okay, it moved left. Let's just keep going until it hits a reward. We're not going to have any fun numbers to actually do anything with. So let's maybe just speed it up. Oh, look, wrote something down in the copy. Wow. Still doesn't have any numbers. Still doesn't have any numbers. Oh, it stepped off the, maybe it didn't step off the end. Yay, all right. Okay, we were in state AB, it moved off the end. Now, the number of correct characters are, the A was correct, wrong, correct, wrong, wrong. So 100 for each one of those, 200 total reward, okay? And now it said the equation used to be up there, and we were just looking at earlier today says, okay, take your value and add in 10% of the reward plus the best you're going to do at the new location. And the best we're going to do at the new, what's the current state right now? So we're at a special goal state right now, which isn't even reflected down there. So I guess that's going to be 0. Okay. But the reward is 200, that's 10%. So there's our 20. Good. In a way, maybe it's a little easier than the last one because the max over the new state. Oh, where it's going to matter is, yeah, well now whenever we move into an AB state, we've got a number there that's going to force updates in some other numbers on the table. Okay. All right. So let's step a bit more. If it's too boring, I'll just hit the run button, but it's so fast when you hit the run button. By the time I turn it off, it'll have numbers everywhere. Okay, let's go. Okay, so you see what happened. New string popped up, copy got erased, cursor got reset. Okay, it's going to be a while before oh, it happened so fast. I blew it already. Okay, see a number popped up there, right? Okay, let's see if we can deconstruct what happened there. Okay, so the first thing that happened is it wrote this B in, right? I don't know if I can deconstruct it. Let's see. It was in an A underscore and it moved to an A, must have moved to an AB state. Dang it. Yeah. All right. I don't want to play guessing games. I'm gonna be wrong and maybe I'll confuse you, and I don't want to do that. Okay. Well, something happened. We must have moved into an AB state there somehow. And we can see, let's see. Yeah, I wish we'd be able to do it. Yeah, so I mean, yeah, sucks. Okay, I'll try to be more careful. All right, it might be better to just let it run. So there's numbers everywhere, so there's always something to look at. But there's a good chance right now we're going to have another interesting circumstance. So let's see if it happens to step left. Okay, it did not. It wrote an A down below. Okay, but now it's in a BA state where it still knows nothing about BA. Okay. Now from BA, it moved left into an AB state. Okay, so it should now get 10% of let's see. What do we want to say? It'll take 90% of its old value for the BA state. 90% of its old value, it was 0. So that 90% of 0 plus 10% of the reward plus the best it's going to get in the new state. Okay. So the reward would be 0. There's no rewards until it gets to the end of the line, right? But the best it's going to get in the new state is 16. Okay. The 10% of that, I can only guess we're getting, there's a floor operation in there somewhere. So we're 1 instead of 2, or more likely 1.6, but it's only the floor is getting printed. Does that make sense? Some sense. This one maybe it's a little harder to get through. All right. Yes, please.
Why is the constant is AB?
So you see where the cursor is?
Okay.
A, B.
Yeah, and we came from B.
And we came from BA. Right? That's why this number is getting updated. We were in BA and we went left.
Yeah, but why is the current state is AB?
Well, you see where the cursor is? I mean, can't you see what's above is an A and what's below is a B? So that's the state. What's above and what's below.
Yeah, I was reading it the same way. I was looking at the top row.
Yeah.
Yeah, so all those things are a mix of A, so it's A dash, it's A with an empty block. I was reading it wrong.
Okay. Yeah, people have some problems with this, and you need to know both of these. So make sure you spend enough time with it. But I'm not going to stop yet. We have time. I don't have a lot more to do. So surprisingly, what I need to say to finish up is not very much, because when it comes to neural nets, there's not a lot of theory. that's worth writing on a board. This isn't a math class. You can actually prove some things about reinforcement learning with neural networks, but they're not remotely at our level, not remotely. It's nothing similar to anything I've done in many decades. So I wouldn't even want to try that. Doesn't really advance our agenda. The learning point at that moment is, well, you need to really try this, and that's what we need the lab for. So that's coming up Friday.
The neural networks considered testable.
Yes, it is. There's like, but you'll see, there's like 3, 4, 5 slides, and then I'm gonna draw a line. Okay. So let's see. Let's take another step. Okay, if we get an exploit, let's just say, okay, we should go right, right? So AB is a state where he thinks he knows it's good to go right. Is it correct? Is that the actual best action in state AB? No. What should it do? It should, well, which means the action is A, write an A. Right? AB is bad. That means the copy is not the same as the original. So it should be writing an A, but it's never been rewarded for this. So it does not know that that's a good thing to do. And it thinks AB is good. It did at least get some reward for doing that. Okay, so let's see if that's what happens. That's the likely thing. Yep, sure enough, it went right. It went now to state BA. AB, you see the value went down from 16 to 15. Does that make any sense?
Is it going down because it did not get rewarded just now? But like, because last time it got the reward because it went off the end of the chain, right?
Yeah.
And here it's stepped right, nothing now.
It's in the middle, right? So it's not going to get any rewards here, right? So let's write the equation one more time, right? So U one minus alpha U of B1 S1 plus alpha times R plus R discount factor times max A of Q of A plus 2. That's our result. Okay, all right, well, let's do the math and make sure it works out. So we just went down. That seems kind of strange. Okay, well, this is 0.9 times our old value. Our old value was 16. Right? We want to see, is it right that it went down to 15? Okay, plus alpha is 0.1. Okay, reward is 0 here. Gamma 0.9. Okay, max over A in the new state. Well, in the new state is BA, and then that max is a 1. Okay? Okay, 0.1 times 0.9, that's 0.09. Right? So, in other words, well, let's look at it this way. We're doing our exponential averaging thing. We're taking 90% of 16 and 10% of 0.9, which is much lower. That's why our number is going down. Okay, and hopefully sense. Actually, we don't have enough decimals. I fear 100% confidence of this one. Right? You do that. Whoops, you get it. All right. All right. This is a pretty hard problem, right? I mean, it takes a bunch of actions. It's learning from its own past behavior, which, as you see, is not really a reliable indicator at this point in its learning. Let's maybe let it go for a little bit here. Wow. Look at this. It's getting no hits. This is really unlucky. It's kind of just going back and forth there. So it's got in a bad loop where it thinks it knows what it's doing. Let's pause. Let's see if we can figure out what's going on here. Do you see it just kind of going in the middle here? Why is that? So in state AB, let's see, I think you can go in any direction. I was thinking this is a little messier than I figured. I think the main reason we're getting jammed is because whenever it bumps over to BA, it thinks it knows that going left is better, which makes it back up. So the only way we're going to get past that obstacle is with some explore stuff. I mean, it thinks it knows what it's doing. So when you say, do the best that you know, it does the wrong thing every time. All right, let's see. Will it ever happen? Oh my gosh. The numbers are, we're re-zeroing the table. Oh, okay. You see, okay, it finally happened. I don't know for good or for bad. We actually got to the right end of the table. Let it run for a bit. I'd love to see that it actually learned something good. I've never had such an unlucky run of this thing. I'm glad I didn't just sit and try to hit step for this kind of an outcome. All right, stuff's happening. All right, let's take a look. When I'm in state A underscore, what's it going to want to do? Is that the right answer?
No.
No. Okay. In state AA, which apparently it's very rarely been in, it's going to want to write a B. That's also pretty terrible, right? It's going to correct the right answer to the wrong answer. AB, it's going to go right. Not good. B under, okay, I like this one. I like this one. And BA, no. BB, right? This one's good too. Those two, which are the strongest numbers, are both seem to be reasonable. Okay, so let's do this because this is so slow. I'll leave it running in the background and let's talk about the next slide. All right. Don't set my machine on fire. All right. So this slide is just so you don't get confused. This is just about, to be clear, this is just about the implementation in JavaScript that's in those apps here. Just don't want you getting confused. There's special like reset actions and goals and goal states that are in there, which don't have meaning outside of my particular implementation. So just don't be confused, right? But it is important as a general phenomenon. So if you're actually training a reinforcement learner in simulation, which is what people do these days, when you get to the end of a run and you stop it because the battle was over or because you're running out of time or whatever, you do need the one point to take away from this is be careful that you don't treat the initial state of the game when it resets as a state that immediately succeeds the end state of the game. All right? So it will start thinking that, in the worst case, again, it depends how your actions are represented, but if they start thinking that the goal state is actually kind of bad because the next thing you know, you're at the beginning of another battle. So just be aware, don't muddy the water like that. All you have to do is just don't learn on that step. It's as easy as that. Okay. All right. All right, so let's talk about this. So this is still just our walk level algorithm. It is more capable than the one we did at the beginning of the week. However, okay, it does change Q values, but it changes them slowly. Yeah, is that not the truth, right? That's why we're letting it learn while we're reading this slide. Okay. Now, the number of states and actions also tends to be large, which does not help, right? So what's the relationship, right? So for every state and every action, that makes one more entry in the table, right? I mean, if it's a chessboard, which has a zillion configurations, I mean, imagine that for every action, every pawn move, which already there's a lot of those, you have to go that crossed with every state of the chessboard. It's an insane number of action state combinations, and you need to visit each one of those to actually learn something. Okay, so that it doesn't take much experience with this to realize that, okay, it's actually a great illustration of Q learning because you can do it without a neural net, but it isn't all that practical except for very small problems. Some people have really small problems, like my colleague right now who's using this for some of his research, but most of us aren't that lucky. Okay, now you can do some kind of obvious things, right? What you can do is, so the action space probably is what it is. It's hard for me to imagine that you'd actually want to say, I'll just won't consider, there's so many actions, I just won't consider these, but maybe in some cases that makes sense. What you could do clearly, with some amount of pain is just reduce the number of states, right? You can say, like, you could take two, well, I don't know. With my simple examples, I don't have a good way of doing that, but let's say, on the chessboard, you could start ignoring what's happening in the corners of the chessboard. That's less important than what's happening in the center. You literally just ignore it. Treat all those states, whether they're the pawns and rook and the knight are in their initial configuration or whether they've been moved away, it won't matter. You'll just treat all those states the same. Okay, that will reduce the number of states, all right. But it helps us in that way. But the problem is it puts a performance cap on the system. You've introduced a kind of blindness to the system where it will now not be able to see. If it turns out that that is the essential difference between two states, whether the rook is in the corner or not in the corner, you've now made a system that will be completely blind to that and is liable to do terrible things in the wrong circumstances. Okay, so yeah, not a generally practical evolve. Very good for learning. I'll defend it to the death for learning. For practice, we use neural nets. Okay, but now what are you going to do with a neural net? The table at least is nice and clear. What you need to do to update the output. I mean, it's kind of a little bit of a pain in the butt, but this is not that hard, right? Spend an hour if it's so confusing to you, and I guarantee you, spend a solid hour working on it, and by the end, it will start making some sense. But what if it's a neural net? So the goal will be, we want to represent the Q function using a neural net. Okay, how are we going to do this? So we'll take a neural net that takes a state. Before I get into this, it's going to take me a while to talk to it. So I got to check on me. See what's in the oven here. This doesn't look great. In fact, I don't think it's been running. Maybe it's too smart to run when the focus is off of the window. That could be the case. Darn it. All right. Let's see. Yeah, it's got all the same stupidity there. All right. Maybe I have to run it before class tomorrow. All right. Okay, so what are we gonna do? So there's actually a couple ways to slice it. It depends how you're going to represent the action. So let me just pick one way just to give you a clear direction here. If there's K actions, we'll create a neural net with K outputs. And the input will have to be sufficient to represent our state, whatever that could be. Okay, so it can be very tiny for some classroom examples. For battlefield simulations, it tends to be pretty big. Okay, and I'm thinking maybe after we finish, let's see how you guys come out with this lab and the next one. But we should have time. We can maybe squeeze one more in there that is oriented toward bigger networks like ones you'll be using. So that's my current vector. I think I could do that relatively easily. And you'll see there, even with a little toy war game, those states are substantial. Okay. All right. But whatever that number is, whatever that number of actions is, that's going to be the number of outputs. And the input dimension, as I said, will be what it needs to be. Okay. So then what we're going to have is this. We're going to have a parameterized Q function. Okay. So if we look at the jth output of the Q function, we could say this is what that is. It represents the value of taking that action, that jth action, in any state you like, just provide it as an input. Oh, but then you also have to tell me what a bunch of weights and biases are, however many are in your neural network, which may be a lot. Okay. Okay. All right. Well, let's say you buy that. Does that make sense to you all, or is there any other ready? Okay, because there's just one more step. Like, okay, that's great. How do you train? How do you actually train? Okay, it should make some sense to you. Okay, so remember what we have on the board there, right? What we were saying and the logic behind the Bellman equation, right? That if this is our Q value for the state that we're in, and then we take action, we take action A1, and we transition to state S2, you get reward R, okay? What we said was these two things should be the same, right? All right, so all I'm doing is I'm saying, okay, let's put a minus sign in between them, square the whole thing, and make that the objective function to your neural. That'll be the function whose gradient you move down to train the weights of your neural network. I mean, in a way, it's amazing. The Bellman equation just looks like a consistency. It looks very far from a recipe for how you do good actions in whatever situation you might be in. Yet that's all that's actually used to train this thing. Just consistency. Just be whatever you think the value is for your states of the world and for taking actions, be consistent. And if you're consistent, you get to a good answer. That's kind of the bottom line. Any questions about this? These are all ingredients you know. That's really it. Okay. You just got to go and that's not necessarily a standard. It might be a little work like at the PyTorch level to actually go and implement this, but to be honest, most of the time we don't have to implement this. Reinforcement learning is just out there. It tends to be built in the systems we want to use. It's not built into the PyTorch level. So for Lab 3, we'll use another package called Stable Baselines, built on top of PyTorch, one more layer of software, and Stable Baselines knows all about fuel and many other. But good. That's good. Good. All right. All right. All right, so let's compare the two. What are the pros and cons of doing what I just said versus the tabular approach that we've learned at this point? Okay, pros of the neural net. Okay, this blow up where for every state and action, you need to make an entry in the table, and then you need to visit it many times to actually have that number come up and be accurate, is gone. It's gone. It's replaced by the magic of the neural net, so to speak, right? So, and the neural net, and the nice thing about the neural net is it's totally controllable how big it is, right? Whereas the size of that table, the size of the action space times the size of the state space is not controllable by you at all. It is what it is for your problem. Okay. Whereas the neural net, you can just say, well, let's try. I can't really afford a neural net that big. Let's take a layer out. Let's have a few less hidden units per layer. You've got total control over that. Now, of course, that comes with some cost. So you take power out of the neural net. Pros and cons to that too, right? But at least it's under your control. All right. Also, there's no, at least in practice, I can tell you, you don't need to visit every state action pair multiple times. So this assumes that your states and actions are represented in a reasonable way for your neural network, right? Because the neural network, how it behaves with regression. To get a good regression curve in Lab 2, hopefully you're all going to give me good regression curves, you don't have to have seen every X value. As long as you've seen enough X values, you should be in good shape, right? Same story here. You don't need to see every state and every action as long as you've seen a representative number of states and a representative number of actions in those states, you should be good. In practice, that's the way it works. Yeah, and right, so this is kind of saying the same thing as it's unpacking what we were talking about there. It will estimate the long-term reward, even for states it has never been in. right? That's the beauty of a neural network, right? It sounds magical when you're talking about actions and states, but if you think about like in terms of a regression curve, that's like saying, wow, once you have your linear regression function, you can ask for values of y and x's you've never seen. Well, of course you can't. That's the whole point of it. You know, all right, but that's the side effect here is exactly what we said. Don't need to visit every action, every state. So, right. And what I would say about this is, well, note the careful wording. Since the neural net is a continuous function, this estimate will be based upon similar situations and is often sensible. Well, same issue with generalization, right? Same thing as when you're doing function regression. It's often sensible, but it depends on choices you make when you build out the system. Any question about those pros? I think they're reasonably stated. Okay, now cons. So if your representations of states and actions are very unfriendly to the neural network, what would be unfriendly? Well, ones that are big data objects and they're almost identical, except they're just one number different somewhere in the representation. Oh, and that means it's totally different. And what actions are good have nothing to do with what you could totally know one state and you will never guess what you should be doing in the other state. That would be very unfriendly. And no one sets up their action state representations on purpose to be like that. Okay, but at least if you're getting bad results, you should be thinking, am I crippling my neural net by a really, by a very misleading representation of the it doesn't matter. And then of course, I just as a generic con here as well. Whenever you got to train a neural net, it's not necessarily going to be a nice day. So, we don't want to do that except when we have to, but these days you kind of have to all. All right. All right. So this is now where I'm going to draw the line for the test. Okay. There's quite a few more slides in here of more advanced material. I hope you will pay attention and try to learn from it because stuff's going to come up in summer. It won't immediately bite you right now. You ignore it all, but it'll bite you eventually. So, don't let it bite you. So we'll start in on that tomorrow. I can do quite a lot of it, maybe even all of it. So a lot of slides, but I'm not going to go deep. This is where it's kind of an inch deep and was covering a wide area. This part of the unit. I can get through a lot of it tomorrow, I think, and then Friday I'll brief the new lab to you, where you can actually see what it's going to take to go out and start experimenting with neural net driven Q learning, and yeah, we're in a good spot. You guys let me move along pretty quickly, I think, unless you surprise me on the test. But the last test you did great, so I blame you if I've been missed. Any questions? All right, take one more look at that. I assume this thing is still just being stupid. Oh, no, wait, hang on. Let's take a quick look. It learned that when there's B in a blank, you should write a B. I don't think it knew that before, did it?
It did.
It did? Is that one of the things it knew?
Yeah.
Well, it doesn't mess up BB. Let's see.
It's doing all right with B's before, but it's doing better with the A's now.
It's doing better with the A's.
Yeah,
it leaves AA alone. Doesn't write a B in. Okay. So you see, yeah, and you yeah, it's just I'll do another run. I'll try to remember to do a run for class tomorrow and tell you how long it takes. It's maybe not. So I hope you don't have the impression this was running the whole time we were off, because I'm pretty sure it doesn't. I think it runs just a tiny bit, then it realizes the focus is off the window, and it shuts down the computation.
Again, the original screen changes.
Oh, is that right?
Just B's and one A.
Oh, yeah. Yeah, okay. So it had already, yeah. But but these numbers are just so low. I just don't believe that it's been running continuously. Yeah, so I think as soon as you get off the screen, it stops updating the screen. That it does right away. It doesn't stop the program or the JavaScript running right away. It lets it go for a bit, but I think it's now smart. It's too smart for its own good. So it now realizes, well, the user isn't even looking at this window. I can stop doing the JavaScript. Okay. Not what I want today, but there you have it. All right. And I'll see you guys tomorrow afternoon.